We're going to see a presentation from AD Consulting. AD Consulting has been founded in Modena in 2011, and it has 5 sites in Italy, providing services for digitalization, computer data centers, systems, and network for industry and public administration. It is one of the founding companies of Smart Mobility Agency to supply specifically the infrastructure of MASA and related operative services.
Good afternoon, everyone. Welcome to the Fog Computing session. First, let me introduce myself. I'm Gianfranco Silvestri. I'm the Business Development and Innovation Manager from AD Consulting. Today, I'm going to talk about fog computing, and I'll be speaking to you about some applications like connected cars, smart cities, etc. Let me start by giving you some background information about the agenda. We are going to talk about cloud computing limitation, fog versus cloud, fog computing characteristics and technology architectures, and a couple case studies and applications, for example, connected cars, smart city, and healthcare. As you are aware, cloud computing is a type of computing that relies on sharing computing resources rather than having local servers or personal devices to handle applications. But as you can imagine, there are some limits. First of all, it is not always connected. In fact, connectivity to the cloud is a prerequisite of cloud computing. In addition to this, some IoT systems need to work even if connection is temporarily unavailable. Another limit of cloud computing is that it doesn't always have enough bandwidth. The cloud computing supposes that there is enough bandwidth to collect the data, but this assumption becomes overly strong for industrial IoT applications. Another problematic is about the centralization of cloud computing analytics, therefore defining the lower bound reaction time of the system. But in several cases, some IoT application might not be able to wait for the data to get to the cloud, be analyzed, and for insights to get back. Last but not least, another important issue is security shortcomings. Be that data protection mechanism in cloud computing, such as encryption failed, it wasn't able to protect the existing data from hacker attacks. Whereas the cloud is up there in the sky somewhere, distant, remote, and deliberately abstracted, the fog, instead, is close to the ground, right where things are getting done. Fog computing is a paradigm that extends cloud computing and services to the edge of the network. Fog computing places processes and resources at the edge of the cloud, often on network devices, while data remains stored in the cloud. This leads to faster processing times and fewer resources consumed. As you can see in this slide, fog computing has a lot of advantages compared with the cloud computing. In my opinion, latency, distance between the client and the server, geographical distribution, number of the server nodes, and type of last mile connectivity are for sure top priority, especially when we're talking about car connected or smart city. What are the top characteristics of fog computing? Geographical distribution. The services and application objective of the fog are widely distributed. Support for mobility. Fog devices provide mobility techniques like decouple host identity to location identity. Real-time interactions. Fog computing requires real-time interaction for speedy service. Heterogeneity. Fog nodes can be deployed in a wide variety of environments. And last, interoperability. Fog components must be able to interoperate in order to give a wide range of services like streaming. Let's talk about the three important pillars of fog computing. The IoT sensors are placed at the bottommost layer of the architecture and distributed geographically. They sense the environment, emitting observer values to upper layers via gateway for further processing and filtering. IoT data streams are made of a sequence of immutable values emitted by sensors. IoT actuators similarly operate at the bottommost layer of the architecture and are responsible for controlling a mechanism or system. Actuators are usually designed to respond to change in environments that are captured by sensors. Fog devices. In the architecture, any element in the network that is capable of hosting application modules is called fog device. These devices that connect the sensors to the internet are generally called gateways. So, what we can see in real life the fog computing application? In this first example, connected car, the fog computer is ideal just because real-time interaction will make communications between cars, access points and traffic lights as safe and efficient as possible. Fog computing will be the best option for all internet-connected vehicles because fog computing gives real-time interaction. And does it work? Yes, it works, and we did it. We did it here in Modena, in MASA, Modena Automotive Smart Area. And what we did, we implemented the real-time reduction of delay times from 3 to 5 seconds to milliseconds, OBU onboard unit support with roadside calculation, communication security from vehicle to fog and from fog to cloud. And by the way, already aggregated data means less cost for connectivity and cloud services. The Internet of Things, IoT, aims to connect billions of smart objects to the Internet, which can bring a promising future to smart cities. These objects are expected to generate large amounts of data and send the data to the cloud for further processing, especially for knowledge discovery, in order that appropriate action can be taken. However, in reality, sensing all possible data items captured by a smart object and then sending the complete captured data to the cloud is less useful. Further, such an approach will also lead to resource wastage. For example, network, storage, etc. The fog computing paradigm has been proposed to counterpart the weakness by pushing processes of knowledge discovery using data analytics to the edges. Let's talk about healthcare. If we take a look today, we will see that healthcare systems in most countries face enormous challenges that will increase due to aging population and the rise of chronic diseases. We also have a growing nursing staff shortage, and much time is wasted in hospitals by manually measuring biometrics parameters and transferring the data between systems. But how can fog computing help us? For example, it can be locations to be more dynamic. New sensors can be added to existing infrastructure, increase the area where patients can be monitored, reduce latency, and improve response time. I would like to thank you for your attention. Feel free to call or to contact me if you need any help, and I wish you a great day. Thank you very much, Gianfranco Silvestri.